Hey, welcome. Today we're jumping into a really key algebra skill, how to look at a picture on a number line and turn it into a clean, simple math statement. It's all about translating what you see into the language of math. So let's get right into it. Okay, you see this all the time when you're on the road. It looks like just a number on a sign, right? But your brain does something kind of amazing, and you probably don't even think about it. It sees the number, sure, but it understands a rule. So let's just stop for a second and really think about that. This sign, it's actually a math problem in disguise. What's the rule? What's the actual mathematical instruction that this sign is telling you to follow? See, your brain immediately translates that sign into an inequality. It knows your speed can be 65, or it can be anything less than 65, but it absolutely cannot be more. You already know how to do this. All we're going to do today is just put some official math rules to what you already get. So, how do we make sure we get this right every single time? Well, we're going to use a super simple but really powerful tool I like to call the three-step scan. Think of it as your secret weapon for turning any graph into the right inequality. And here it is. It's just 3 quick checks. First, find the boundary. That's just the number where everything kicks off. Second, check the circle. Is it empty or is it filled in? That's going to tell you if the number itself is included. And third, check the direction. Which way is the arrow pointing? Left or right? That'll tell you if we're dealing with less than or greater than. Okay, theory is great and all, but the best way to really get this is to just do it, right? Let's take our 3-step scan for a spin and work through a few examples together. All right, first one up. We've got a number line, there's an open circle hanging out at -2, and the arrow is shaded off to the right. Our mission is to write the one inequality that describes this whole picture. Let's run our scan. Step 1, find the boundary. Easy enough. Where does it all start? Right there at -2. Step 2, check the circle. It's an open circle, which means the number -2 itself is not included. It's the starting line, but you can't stand on it. Step 3, check the direction. The arrow's pointing right toward all the bigger numbers, so we're looking for numbers greater than our boundary. So what's our final answer? Well, we need a variable, let's just call it x, to represent any number in that shaded area. And our scan tells us that x has to be greater than -2. And notice there's no little or equal to bar under there. Why? Because our circle was open. Okay, round 2. Let's try another one. This time, our circle is at the number 4. But look, it's filled in. And the arrow is pointing the other way, to the left. So what's the inequality for this one? Let's run the scan again and see what's changed. Step 1, the boundary is 4. Got it. Step 2, the circle, now this is the key detail here. It's closed. It's filled in. That's a huge deal. It means the number 4 is included in our answer. And that means we're going to need that or equal to bar. Step 3, the direction is left toward the smaller numbers, which means less than. And boom, that's how we get our answer. The variable x represents all the numbers that are less than or equal to 4. That little line underneath the symbol, that's all thanks to that filled-in closed circle. See how every little detail matters? All right, last practice run. Don't let the 0 freak you out. It's just a number like any other. Here we have a closed circle right at 0, and the shading goes off to the right. You know the drill. Let's do the 3-step scan one last time together. Boundary, 0. Circle, it's closed. So what does that mean? Yep, we're going to need that or equal to bar. And the direction, it points to the right, which means greater than. You know, what this graph is actually showing us is a picture of all the non-negative numbers. And there you have it. The inequality is x is greater than or equal to 0. See? That 3-step scan, it just works. It's almost like a cheat code for these problems. Quick, easy, and always gets you the right answer. So you've got the method down pat. But before we go, I want to give you a pro tip and talk about a couple of traps people fall into. Avoiding these is what separates getting most of them right from getting them right every single time. Okay, this is huge. This is probably the number one mistake people make. Always, always, always write the variable first. Now you might think, well, 5 is less than x means the same thing, and you're not wrong. But look at the inequality symbol. It's pointing left, while the arrow on your graph is pointing right. That's just asking for confusion. If you always start with x, your inequality symbol will always point the same way as the arrow on the graph. It's a simple trick that saves a lot of headaches.
And the other quick tip is super simple: respect the open circle. If that circle is not filled in, do not put that equals bar underneath your symbol. That boundary point is not invited to the party. No bar, that's it.
So you might be thinking, okay, cool trick for my math test, but when am I ever going to really use this? And the answer is probably a lot more than you think. This skill is everywhere. Just think about a smart thermostat or even the AC in your car. It's running on a simple rule, right? Somewhere in its code is a little line that says something like, if the temperature is greater than 90, then turn on the AC. That's it. That's an inequality, doing its job right there in the real world. It's the exact same logic. And looking ahead in your math journey, this isn't some random topic you'll forget about. When you get into more advanced stuff, like functions, and you have to talk about domain and range, you're going to realize it's the exact same skill. You're just reading these rules off a way crazier looking graph. So getting this down now, it's like building the foundation for the whole house. So look, you've totally nailed how to read the story that a graph tells along a single flat line. You've mastered one dimension. But what happens when we add a second dimension? What happens when the story doesn't just go left and right, but it goes up and down too? Well, that's where all this is headed next.